Hello! Today we're going to make and record the observations, measurements, and approximations, interpret and evaluate experimental observations and data about the kinetics and chemical equilibrium for my laboratory exercise 002. We're going to study the two experimental setups, answer what is asked appropriately. For number 1, identical pieces of brass were placed in two different boiling liquids for 12 hours. The graphs show how the mass of each piece of brass changed. So we have a two graph here. We have a graph A and we have a graph B. For graph A, we have a brass in boiling acid solution, and for graph B, we have a brass in boiling basic solution. Where is the question for letter A? Give one similarity in the change in mass of the brass in both liquids. As we can see the graph, this and this, similarity. Okay, when the brass placed in both liquids, the graph shows us how the mass loss, concentrations versus time are both increased or directly proportional to time. Okay, for letter B, describe two ways in which the loss of mass in graph A is different from that shown in graph B. In graph A, here, this, okay, shows that the mass loss of concentration is constant to time. It's continuously increased, and there is the possibility to increase more if it keeps the amount of acid constant. And for graph B, look at the graph. The more time it takes, the slower you're going. The line stops at the mass loss of 0.17 and the time of 7 hours, and go to 12 hours of time and the mass loss of 0.18 at the same level. Okay, for question letter C, list 3 different safety precautions that are needed in doing these investigations. Okay, need a concentration. It's best to wear rubber gloves that cover your hand and wrist. Wear goggles or stand as far away from the bottle of acid as you can. If possible, wear coat that will surely cover your arms. Also, it will protect your skin to avoid being injured if the acid splashes up accidentally. If you're going to make this investigation, this experiment, you need to do this. Okay, for number 2, the rate of reaction between hydrochloric acid and aqueous sodium thiosulfate was investigated. When these chemicals react, they form a precipitate which makes the solution go cloudy. The formation of this precipitate can be used to show how fast the reaction continues. 5 tests were done using the tools shown below here. Here's our eye. We're going to look down if this, and this is the 10 centimeters cube of hydrochloric acid. We're going to put it here, and this is a 500 centimeters cube of conical flask, this bottle, and this at the inside of this conical flask is the aqueous sodium thiosulfate, and this is the printed sheet. This. Okay, for test 1, using a graduated cylinder, 60 centimeters cube of aqueous sodium thiosulfate was poured into a conical flask. The conical flask was placed on a printed sheet of paper. 10 centimeters cube of the hydrochloric acid was added to the solution in the conical flask, and the stop clock started. The time taken for the printed words to disappear from view was measured. Okay, for test 2, using a graduated cylinder, 50 centimeters cube of aqueous sodium thiosulfate was poured into a conical flask, followed by 10 centimeters cube of distilled water. The conical flask was placed on the printed sheet. 10 centimeters of cube of the hydrochloric acid was added to the solution in the conical flask, and the stop clock started, and the time taken for the printed words to disappear from view was measured. Okay, for test 3, test 2 was replicated using 45 centimeter cube of aqueous sodium thiosulfate and 25 centimeters cube of distilled water. So the time taken for the printed words to disappear from view was measured. Okay, for test 4, test 2 was replicated using 35 centimeters cube of aqueous sodium thiosulfate and 15 centimeters cube of distilled water. So the time taken for the printed words to disappear from view was measured. Okay, for test 5, test 2 was replicated using 10 centimeters cube of aqueous sodium thiosulfate and 20 centimeters cube of distilled water. Okay, use the stop clock diagrams to record the times in the table and complete the table. Okay, this is the stop clock diagram. I'll show you here. Okay. For test 1, we have a 60 centimeters cube for volume of aqueous sodium thiosulfate, and we have a 0 volume of distilled water because we use a hydrochloric acid, and the time for printed words to disappear is 45 seconds. For test 2, 50 centimeters cube for volume of aqueous sodium thiosulfate and 10 centimeters cube for volume of distilled water, and the time taken for printed words to disappear is 55 seconds. And for test 3, we have a 45 centimeters cube for volume of aqueous sodium thiosulfate, and we have a 25 centimeters cube of volume of distilled water, and we have a time for printed words to disappear is 1 minute and 6 seconds for equivalent to 66 seconds. Okay, for test 4, we have the 35 centimeters cube for volume of aqueous sodium thiosulfate and 15 centimeters cube for volume of distilled water. A time taken for printed words to disappear is 1 minute and 18 seconds, or equivalent to 78 seconds. For test 5, we have a 10 centimeters cube for the volume of aqueous sodium thiosulfate and 20 centimeters cube for volume of distilled water. And the time taken for printed words to disappear is 2 minutes and 20 seconds. 2 minutes is equivalent to 120 seconds plus 20 seconds is equal to 140 seconds. Okay, we're going to plot the results on the grid and draw a small line graph. Okay, here is the test 1, test 2, test 3, test 4, and test 5. For test 1, we have a 60 centimeters cube of aqueous sodium thiosulfate, and we have a 45 seconds of time. Okay, for test 2, we have this 50 centimeters cube of this volume of aqueous sodium thiosulfate, and we have a 55 seconds of time. And for test 3, we have test 3, we have a 45 45 centimeters cube of aqueous sodium thiosulfate, and the time for printed words to disappear is 1 minute and 6 seconds, or equivalent to 66 seconds. And this one is, we have a 35 centimeters cube of aqueous sodium thiosulfate, and the time of this 1 minute and 18 seconds. It's equivalent to 78 seconds. Okay, and for the test 5, we have a 10 centimeters here, 10 centimeters cube of aqueous sodium thiosulfate, and we have a 140 seconds of time. Okay. And letter C. From your graph, infer the time for the printed words to disappear if test 2 was repeated using 15 centimeters cube of aqueous sodium thiosulfate and 15 centimeters cube of distilled water. Show your solution on how you come up with the answer. As we can see the graph, here is the 15 of aqueous sodium thiosulfate, and the first line here, okay, we stop it here. We're going to stop it here, and we get a 125 seconds. Why? Because our graph is from right to left. Okay, so I'm starting it here to here. So the time taken is 125 seconds for 15 centimeters cube of aqueous sodium thiosulfate and 15 centimeters cube of distilled water. For letter D, in which test was the rate of reaction greatest? For question letter D, in which test was the rate of reaction greatest? Explain why the rate of reaction was greatest in this test. For me, it is the test 1. Test 1 has the rate of reaction greatest. As we can see, the volume of aqueous sodium thiosulfate has 60 centimeters cube, and the time for printed words to disappear has 45 seconds, and the volume of distilled water is 0. So the concentration versus time must faster than the other test because they use a hydrochloric acid only. They did not use a distilled water.